Previously on The Bald Engineer.
Oh God, wait a minute, what? Ooh, you're dirty. Oh no. James, you're looking at the wrong chip. Oh my God. Excuse me. Farts. And F stands for fun. Pick. Yep, fell right for that one. Tab is ground. Oh no, 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 no. New work. Oh my God, are you kidding me? And why is it triggering now? That could have gone a little better. Good evening, or morning, or afternoon, whichever works for you. How's everybody doing? I'm James, you're you, and we're going to do some work on a state mode logic analyzer. I had to think of what I was calling it. Okay. Yeah, so Alex, so in the social media post I mentioned E9, which is the essentially the name for the problems with errata. E9 is the name for the problems with the RP2350. I don't actually think it's going to be an issue because I'm going to put buffers on the board anyway, and so I'm not going to go direct into the I/O. So yeah, at first I was thinking about just going direct into the chip, but I really want to have some 573s or 245s out there. 245s. I don't know why I was thinking 573. So yeah. Anyway, all right. Let's just get right into it. Let me adjust a couple of things and then we'll be ready to go. Go, 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 go. This can be there, that can be there, that can be there. That looks right, that looks right, that looks right. Oh, E9 is errata 9. Huh. Yeah, that makes sense. Dummy. Okay, so here's where we're at the state mode logic analyzer. We've actually gotten rid of the timer circuit and the clock delay circuit because I have prototyped both of those in it's in an RP2040, but the code that I'm using is essentially the same that we'd use in the 2350. So those two circuits are gone. Yeah, so that's a good sign. So, the Twitch chat, the phone number requirement goes away after a certain amount of time or something. I don't remember. I have to go back and look at those rules again. So, all right. So one of the things I want to do, we were just talking about. So the 2350 has some I/O issues, which is unfortunate because I was originally just going to have signals go direct into the logic analyzer, but I don't, or into the RP2040. But I think instead I'm going to have buffers, and I don't know. I just think it makes more sense to buffer the signals before they go in. The other thing I'm giving some thought to is how to make an adjustable power supply for these buffers so that it would be possible to adjust these to have different input thresholds, which we could do the same thing on the 2350, but I like the idea of having the probe inputs be separate. So oh, nice. Congratulations on having an interesting enough product that somebody on Ali wants to copy it. Sorry, I know that's probably not that's probably not the kind of congratulations you want, but yeah. So what we're gonna do here is I'm gonna move this down here because we're gonna copy this circuit a couple of times. Press O, oh, not I. I don't know what I is. I'm gonna hit O here. Oh, no, it's on this one. So O is a magic key because I wonder if my thing still works. Let me try something real quick. Common elements. Oh, I think I have to run a program for this. XY unrouted media. I thought I had a keyboard overlay. Maybe not on this setup. Or did I put it? No. Okay, I don't know where it's at. I'm not going to try to find it. Use a OSS firmware and get $1 million in start or in Kickstarter. Yeah, actually, there was a discussion in the crowd supply Discord the last couple of days. Somebody doesn't want to make their project open source, and so they're trying to understand what that might mean. There we go. Something like this. No, that one was right. That's weird. Okay, I see what I'm doing there. Hey, Ian. Yeah, it was great to see you at VCF Midwest, which was this last weekend. So this was probably my third year going, third or fourth, and they got a new venue this year, and it is so much nicer. And not to discount the previous hotel that they were at, but the Vintage Computer Festival, just the Midwest, just outgrew that other venue by orders of magnitude. And so now it's more like in a convention center, and it actually just feels more like a conference or trade show. And it wasn't nearly, at least Saturday morning when I went, it wasn't nearly as confining as I remember it. So yeah, it was good to see you, man. Hope you had a good one. Soon it'll be a stadium. Yeah, right. I'm actually surprised. Well, maybe it's because Vintage keeps sliding. So maybe as Vintage slides, there's actually a growing number of people that are interested in vintage computing. But I'm just surprised that it's even as popular as it is. So, and it's really cool. Like people like Ian, who has the sound card emulator. Is it Pico Guys or Pico Gus? Because I think I always said Pico Gus, and I heard you say it different. But it's just like there's hardware like that, and then there's always somebody that, or there's always something that like new that's somebody's come up with. I had a really great conversation with somebody about logic analyzers. She had a 16500 connected to an Atari 2600 and a Tektronix logic analyzer that I had only ever seen pictures of. I I'm like actually really jealous of it. It's totally not usable, but I would still like to have one. Pico geese. I like that. I like that a lot. Probably too much. So anyway, what do you guys think about adding a digital potentiometer to an adjustable linear regulator for the VCCs of these buffers? Because I would like these buffers to have an adjustable VCC so that I can change their input thresholds, which then makes me think we have to have an adjustable VIO on the 2350, even though I really don't want to. I might have to think about that one a little bit more. Basically, what I'd like to do is change these buffers so that they're more optimized for either 5 volt or 3.3 volt or maybe 1.8 volt, just because that's one issue I've seen with the analog discovery is that its V threshold is like 2 volts, which in a 5 volt system, I think it's 2 volts. But in a 5 volt TTL system, it's high enough that the logic analyzer thinks it's a 1, but the digital logic should ignore it in the circuit. The dual supply, use buffers with ABs. Hmm. Oh, look at that. My green screen is not keyed out. Oh, I know why. I know why. Yep. I was trying to actually make the video smoother. Whatever. LCV. What's a 8T? Hmm. Um. Hmm. Why did I delete them on here? That was dumb. All right. So I need to create new signals. So I'm just going to start with buff 16. And then we're going to go up to, I think I'm going to go to 32, even though I don't think we actually get 32 signals with this. And then I can do something like this. Because I was actually thinking about building I don't know. I'm not sure yet. Okay. And then, oh yeah. Okay. Except I think one of those is going to end up being clock because we're not going to get 32. We actually don't get 32 signals, do we? No, we do. So then I need another buffer for the clock. Oh, no. Oh, no. Ow. Oh, dual supply. Oh, okay. Oh, hold on. Okay. Now I see where you're going. I misunderstood what you guys meant by dual supply buffer. Yeah, that's what I need. Let's try opening that. Huh. Okay. 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 Yeah. 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 I like where this is going. Why are there 3 supply pins? What's the difference between... So the direction... Oh, I see what they did. They used the direction and the... No. Or it's a 20... Okay, it's a bigger package. Okay. RP2350, is that the new one? Yep, it is. Welcome to the stream, K1. Okay. All right, let me do this. Well, so what's this come in? Well, let's go to Octopart and verify. Can we actually buy these? Wait a minute, what? Oh, I must have clicked it without realizing it. Oh my goodness. Why are these like what? Okay. No. Okay. SO24s, they're less than $2. That's not outrageous. Yeah, I think we're going to go this direction. Well, I really thought we were going to get into the PCB today, but I think we will. I want my goal with the PCB today was at least to get to a point where we could start to lay out what the chips are going to look like, because the whole form factor of this thing has changed. So, okay. So then, okay. Thanks for this suggestion. I think we're going to use this buffer because I do want to try and do the linear regulator with a digital pot so that I can adjust the one side of this, and then we'll figure out which side we're going to adjust. But what I wanted to verify is what's the correct footprint, because for the moment I'm less concerned about well, I don't know what I was about to say. So small outline package, and it is a 4mm body, a 4 by 8.5. Okay. So do we have this part already? Ooh, yeah, it sucks when you forget to do the gold finish. That's not like that's something you can add yourself. Well, I guess you could. I just don't know how you would do it. Oh, man, I really like it when part or these things already exist, even though I'll probably end up changing it. All right, so let's do this, and then let's go ahead and add let's go find the correct footprint so that you know what, I keep forgetting there's a F hotkey that does footprint placement. And so now with this new chooser, which I used to super hate, but I'm starting to be okay with it. So this is a 8.7 by 4. Is it an SOP or not? I don't think this is an SOP. I think this is a, what's its pitch? Oh, maybe it is. What's this pitch? Yeah, that actually sounds right. I mean, what I still don't like is that I don't have any rulers that I can go and modify, but I think this is the package we want. Like, see, so how do I guess what I have to do now is copy this and then go to the footprint editor. I don't like this. It was so much better before where the rulers and the quick measurement the delta measurement worked inside of the chooser, so that all you had to do was, okay, well, whatever. Because what I wanted to verify is, so if I look down like right next to me, one box over, yeah, so this pitch is 0.365, and then from here to here is 3.1, 3.8, and there to there is 8.7, which I think is what this is, right? 8.7, 3.9. Yeah, that sounds right. 0.65. Yeah, so this is that. Wait. The Mauser part number ends in NSR. This is DBQ. I'm looking at the wrong package. Yeah, NSR is a SO. So I'm looking at the wrong. So I correctly found the footprint that matches that drawing, but it's the wrong drawing, which has only bit me 100 times before. Yeah, you know what I'm actually thinking? This might not be a good approach to go. So this is a 5 something by 15 something. And are you saying that KiCad may not have this one? Let's just do this. Package. So SO24. So this is, I already forgot what numbers I just said. So we had, so this is a 15 by 5.3. And this is a 15 by 5.3. Okay. So that looks like that's the right package. But what I'm thinking at the moment is this is 15 millimeters tall, right? So check this out. So if I come in, if we go into, I don't have PCB open yet. I haven't used kit yet, or KiKit or KeyKit. I'm getting close though. I think for my power supply adapters, I'm going to try to get a panel of those made, because I've got 4 or 5 of them now, and I think I'd like to just get one panel of all of them. So here's where I was going to go with this, is if I take this footprint and just kind of just do this real quick. Look at this. Because we're going to have at least this many. Plus, we've got to also buffer the clock somehow. So that's a problem. Which, you know what? Maybe this isn't so bad after all, because it's about the same width that the board was already. And it'll be a hell of a lot easier to route this than these T-SOPs. Also, I can hand solder them. That's something that I think I sometimes forget. Although it would be nice to have somebody else assemble these. 3,000, $180. All right. What else could we do? Oh, man, what would be really nice is if there was a single gate or 2-gate um yeah, stack them on two sides. That's a good point. Well, I think we're I mean the thing is I'm going to have two of something like this anyway. So the length of the chips actually won't matter. Um but I'm stuck thinking about what to do about the clock. I'm not opposed to adding another, and maybe we could just put the other buffer on the other side. Maybe that's what we could do. Okay. All right. Gotta think not let's think through this a little bit more. We don't need the PCB to do this. So for the moment, we're gonna have to do something like we're gonna have 1, 2, 3, 4 of these, and then we have to have a fifth one somewhere, apparently. Or we don't get 32 signals, which I really do want 32 signals. Or do we just say you only get 30 bits? Because I haven't talked or thought about this much yet, but I was also thinking about adding at least one signal as a qualifier, because I remember on the Agilent analyzers you could have there was a clock and then there was an additional pin to qualify, and so the idea was you could have maybe some circuit somewhere that, well, qualifies the signal. So it gets weird. KeyKit gets weird with zone fills. Oh wow, that would have been bad. Is there a two? Oh, is there? Well, but is the 2T? Okay, hold on, hold on. We'll look at this one for the moment. I'd rather do this one, even though it's not the package I want. So what is this? It's a bus transceiver, LVC. Yeah. Okay. Okay. So what's the difference between a 45 and a 245? So the only real negative is this doesn't have a output enable, but I could probably avoid that. Um, Hmm. Yeah, I guess what I'm trying to figure out at the moment is why I should have. Where's the stupid part number at? I don't want to type it in again. Oh, no. Oh, come on. And I didn't copy it. Is there a 16T245? Um, so I'm okay. I kind of don't want to go lower than I don't want to go bigger than 8 just because I think it limits the chance I'll ever use it for anything else. I guess I'm stuck on what's the difference between a 45 and a 245 because I think I actually want a 45. Maybe I don't want them at all. Yeah, about that. Come on. Really, 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 really. I get why they're so small, but also why are they so small? Um, okay, so this is for the moment. I'm just going to go with this and say, okay, this solves the immediate problem. I want to move forward. And so, what's our packaging options then? So, what of these three packages is the largest? Because I definitely don't want to solder that. And even if I get somebody to assemble it, I don't want to deal with it. SM8. Where's the drawings? My name is Simon, and I like to do drawings. Tech scope. Of course, it's TI. Huh. DCT. Okay. I'm just going to assume that you are correct because you guys usually are. And we'll just go and look at that. What's the difference between these two things? 74 LC245 DCT RE TT. I'm going to guess that's the difference between a real. Why are these so much cheaper though? DCT, DCT. Well, TR that's tape and reel. Yeah, so like, why are these? Those sound really inexpensive. All right, whatever. Okay, so let's add this. No way. No way. No way. Oh, that's awesome. I think that's the wrong. Wait. I just noticed this. I never saw this before. Default package. Nice. So is SM8 VSOP or is it something different? Because I didn't even pay attention. I don't like that they don't have the, yeah, it's different. Okay. So I'm going to select this. I'm going to do footprint and then not do that filter. I don't like that that came under ZTEX. Oh, VSOP is the largest? Wait. Push. Okay. Or does, when they say TI name, do they want DCT? Yeah. Oh. All right. So what is this? 2.308 DCT. Yeah. I don't know. There are no drawings in this data sheet that I could find. They, the only thing they provide is this table. So let's do this since they were too lazy to do it for us. So then I got to come in here and be like, all right, if I say package family of SM8, is that what this one wants? No. And if I say, what if I say DCT here? Nope. All right, so DCT 8 SOP. Can I put in a part number here? No. Okay. Okay. The problem, TI, is that your your package names have me confused. Why can't you just use regular? Why? Or do I just get the VSOP because then I know which one it is? Like, is SM8 supposed to be small outline 8 instead of SSOP? Okay. You know what? I'm just going to assume that that's what that is, that it's SSOP. I'm not in the mood for this at all. So P8, and then I got to figure out which one of these it is, which if this is the correct diagram, then it's 2.8 by 3. Two 2.8 by 2.95. Yeah, it's definitely not that one. And it's neither of those two. Yeah. Yep. And the pitch is 0.65, right? Okay. All right. I'm just going with that. We're just going to go with that. Okay. Enough of this. We put the footprint in. Okay. Let's just move forward with this for the moment. All right. Pinto is asking, when creating footprints for through-hole components, do I use ratios to determine the lead hole and pad diameters? I will let chat try to answer that question. So when you're doing through-hole footprints, how do you decide how big to make the hole? The reason I'm saying that is because I very rarely make through-hole footprints. And if I do, I just go and look at the hole size for something that's similar to the thing I'm creating a footprint for. I mean, most parts should have a diagram that tells you how big to make the holes. And so you would go based on that. So all right, let's try this, see how this works out. How do I want to do this then? I need more space. So this is going to come down here. This is eventually going to be over here. I want this here and this down here. So I can move all this over here. And now, because the other thing is we're going to have to rework the power in a minute. Man, yeah, we're not getting to the PCB. Okay. Now, here's what I'm going to do, because I don't want to make a decision on this yet. And now that we can do this, I'm going to call this VCCA and this one VCCB. And then we're just going to, at the moment, tie these both to 3.3 volts. But this is not where that's going to end up. I want to have like someplace for this. But I don't want to change these symbols later. So I'm basically just saying, okay, for each of these parts, we're just going to figure out what we label it, how we power them later. Okay. So then, also I need to turn this back on so I can see where things are supposed to be. So I'm finding this exercise somewhat funny because I had a recruiter reach out to me for a job that's related to logic parts. It turns out the job doesn't exist, and I don't think they realize it because after a month, they're like, "Yeah, the client hasn't gotten back to us yet." I'm like, yeah, it's because I contacted the hiring manager that would be for that job, and they're like, "We're not hiring that position." And the recruiter's confused. Anyway, I just think it's funny because it's related to logic parts. The did I give this one a? Yeah, I think we got the 2T45 taken care of. Come on. All right. So we're just going to delete those. The caps we'll keep for the moment because we may actually need them. Well, we will need them. I just don't want to figure it out at the moment. In fact, let's just do this. I don't know what I just did. All right. And then, nope. Move this to here. And I got 1, 2, 3, 4, 5, 6. So then we will 5 and 6. All right. We're getting somewhere. I don't know where, but we're getting there. Now we'll take these over here. And this is going to be fun. You know it's going to be easier? No, because it won't shoot. I don't want to click 100 times. I can't think of a trick other than doing these. Oh, come on. Okay. Align items to grid. Nice. Okay, well, we got to move everything anyway. Great. That's just great. This is a whole bunch of clicks that I don't want to do. Might as well, you know what I should do is just do something like this. I just realized maybe I do have a shortcut. The other thing I could do is go and just change the symbol. All right. Well, that's fun. Not. All right. Click, 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 click. I don't understand why I did this way. I don't remember what I was thinking. Oh. I just realized how to do this fast. I can't believe it took me this long to think of it. In preferences, in the schematic editor, repeated items, I want it to be 200 mils. All right, so then I should be able to do a, hello, what are you doing? Now I should be able to do a wire and then just do insert. Okay. And then what I'm going to do is, see, what I don't understand is why did I do this? I don't know why I didn't just have these come over here. Oh, shoot. Now this is a little trickier, I think. So I think KiCad 9 is going to add a selection filter for schematic, which would be really nice for right now. So what I'm going to do is click and hold so I can make sure I get the symbol each time. Since it's trying to select the, what do you call that? The resistor. What did I just say? What did I just say? I swear, sometimes I wonder about myself. Yeah, so then we can do the insert there. That works much better. And then now what I'm going to do is while I'm doing this, we're going to make a label for N00. And I'm just going to put it here. And then we'll do up to 31. All right. And then I'm going to highlight these and hit Y so they're upside down. And then I can just bring these 7 right here. And then we can do a wire. And now we can use the insert key to do the rest. Okay. Now we're cooking. That works much better. Hey, Silent, good to see you. Yeah, so here's the thing. Uh this is drawn very poorly. For some reason on the other buffer, on the other design, I did it this way, which these are still, this is actually still, yeah. So why don't we go ahead and draw it correctly? And I just will have to not remember why I drew it strangely the last time. Because I know where this is going. Schematically, this looks more correct because it should be the inputs are coming in and then they're going over to the chip because of the way we've laid everything out. But for some reason, I moved them on the other design, and I don't remember why. Like I no idea. So try something. Nope. Insert trick does not work with that. Although, you know what it probably will let me do is if I copy and paste this, this is a lot faster. And I don't really care about these designators. I'm going to end up redoing all the relabeling everything anyway, so I don't really care. We'll do a wire to there, then we'll insert all of that. But then these need to change their name because they're not really, that's okay. I got to remake these anyway. be 0. And then we'll do this. And I'm just going to hold insert down for a while. All right, highlight them. We'll hit Y, and then I want 1 through 7 or 0 through 7, roughly there, and then 8 through 15. We'll put roughly up to here. And then we will do a wire to here. Nope, that's not what I want. I want a wire to here. Insert a bunch of stuff there. And now we can do, wow, this is so much faster. All right. And then we can bring this over here. We'll X these. Just to make life easy, I'll X these so they're ready. So that's looking a little bit better. I don't really care about the output enable because I'm just going to always enable them. Is there distribute evenly like PCB new? I don't think so. There's nothing there. None of the what I would say alignment tools that are in PCB are in schematic, and I don't know if that's changing with 8, but I do understand why. It's kind of disappointing. Or maybe they'll change in 9, but yeah, 8 doesn't really have anything useful there. I mean, I guess with the new grid overrides, you sort of don't need something like distribute, but it would be nice if they had it. Not insert label. So let's do buff 0, 0. All right, even though we already have those. I actually don't agree with what you said about output enable on the 245. I thought output enable was relative to direction. Where's the truth table? Yeah, I think output enable is relative to the direction. So it doesn't, because it, for all intents and purposes, it doesn't matter which way you do this because it's transparent, essentially transparent once you configure the direction pin. At least that's how I've always used it, and I haven't run into anything. Like for some reason, layout wise, I did it the way that I had it a minute ago, and I just don't remember what that reason was. And I'm not really in the mood to argue with anything. Yeah, that's much faster. I probably thought of it as I want it to go from A to B, but the schematic looked funny. Oh, VCCA is what you're saying. Okay. 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 Now I understand what you meant. I misunderstood. Yeah, you're right. Okay. Yeah, so the voltage levels of these are going to be relative to A, which I want these to be on the A side because the A side is going to be what's connected to the fixed voltage. Now I understand where you're going. Thank you. I knew I was missing something. I just couldn't figure out what. And it makes sense because I haven't used this one before, so I wasn't thinking about what you brought up as per my usual. I should have, you know, what I should do. I'll just keep doing it the way I'm doing it. And then this should be buffer. I need to move these columns so that this makes more sense to me. So there should be buffer and then B and then in. All right. Yeah, something like that. And then this will go over here. Man, look at all these fun tricks we're doing. I really like this program. You know, here's what I'm going to do. It's a shame I can't just do this for a living. Nope. All right. I'm not worried about the clock one. We'll deal with that in a minute because I've got some thoughts on that. All right. Okay, so where are we at? Wait a second. Did I add one too many? 0, 8, 16, 24. Huh. Oh, I know why. I know why. Because earlier I was thinking we were going to need one for the clock signal. That's cool. Whatever. We can handle that. Making schematics for Lane is boring. Hey, Sion. You guys don't know, Unexpected Maker streams on YouTube, and he sells fantastic things. Years ago, we made the Whopper. We got the Whopper kit, which replicates the code. What is it? The code break. The code key from I was going to say warplanes, war games. So we did that one a long time ago. Then when I was working on the what do you call it? The ultrasonic parking meter, which I never finished. We were using the 7-segment displays that he made using NeoPixels, which are really cool. And then in the BaldSense video, I used his Feather S3 to power the BaldSense. That was really fun. Plus, he just released a bunch of cool stuff too, new stuff. So go check him out. Things trademarked. Right? For those over on the Twitch side of things, if you're new to the stream, thank you for the follows. I totally forgot to have that window open. Yeah, Alex, I got what you're saying now. Is if the output enable and direction are referenced to VCCCB and I'm yanking its voltage around, that's going to cause problems at some point. It's just not going to work out well. Okay, so test points, I know how I'm going to handle those. I don't even know if I want them. I don't think. No, we're gonna do them. So I think what I had to do was how did I do this before? Yeah, okay. So I think I told annotation to use anything after 100. And then that way it would number these correctly because I wanted them, these test points to have a special numbering system. Okay, there we go. Now we can worry about how we're going to do the clock. And then the connector. Hmm. So for the clock, I guess what I was going to say is we'll have a pin called clock and a pin called qual. This will technically be B32 and B33. And then I'm just going to call them clock and qual over here. All right. And then over here, I actually do not want to do that. I'm just going to call this spare. Yeah. Change my mind. Change my mind. Or the other thing we could do. Okay, I know what we could do. What if I'm having this idea. What if we did an AND gate? Let me think. I'm thinking out loud. I'm going to think out loud on this one. But what if I said, what if we did something? You know what I should have done? Nah, it's still not the way I want it to be, but this is closer to reality. Something like that. All right. So what I was actually thinking is, what if I said we do something like this? I have not looked at that weird offset yet, but that's actually what I was just thinking of in when I was thinking about adding a qual signal into this mess of things. But no, I haven't looked into that what you brought up last week. Um, so last week Christian brought up that even though the datasheet suggests you can pick any 16 or any 32 signals within a group, it may actually only want to be offset by 8 or 16 or some other issue where it almost seems like the SDK is not letting you do what the chip data sheet says you can do. But yeah, no, I didn't look into that yet. Uh, I'm I mean, I before I make a PCB, I'll definitely check into that, but at the moment I'm not too worried about it because I think I have enough signals left over that we could rearrange stuff so that I could get clean boundary breaks. So that's why I haven't worried about it, just because at this point, I'm more looking at this from a do I have enough resources point of view. So where I'm going with this is what if so we have this signal come in that's qual. And then what if we just tied qual high or pull it up high? Right? And so then the idea would be now, ideally, oh, I don't want to shoot. This is the wrong gate. It doesn't matter at the moment. I can deal with that later. The name of this software is KiCad. KICAD. Because actually, what would be really okay? So let me actually. What is an AND gate? Is it an 8? Okay, that's fine. Let's do this for the moment because I really I just kind of want to draw this out because I think what I actually want to do actually maybe I do want an AND now I think about it. Because what I almost want to do is this. I'm having a let me draw this out and then explain what I'm thinking this is going to do. And maybe I can't do what I want to do, but what I was thinking is I want this qual signal to come in and it should be a high or low, right? Um, Ideally, we should be able to qualify based on it being high or low. Let's just for the moment say that it has to be an active high signal. In which case, qual would have to get pulled down. But I want to ignore it sometimes, right? So what I think I actually want, I guess what I'm doing at the moment is I'm actually trying to figure out what I want, and then I'm going to figure out what gate actually gets us there because I'm not sure which gate I need or gates. Because what I'd kind of like to do is I want so qual And then I want a qual enable, which will come from the 2380, the 2350, because they okay. Which actually, I just realized I do want this to be. All right, so qual comes in and he gets pulled down. And then qual enable gets pulled up because I'm not going to rely on the pull-ups or pull-downs in the 2350. So then the 2350 pulls so then that way, if this is pulled high, then this is basically putting out. So what do we got then? I'm just going to call it qual and enable. So if, and then what am I trying to do here? And then our output, right? So if qual is, oh, I don't know what I'm out. So if qual is a 0 and enable is a 0, or qual is a 0 and enable is a 1, or 1 and a 0 and a 1 and a 1, right? So what's the truth table for NAND is if both are 0, then it's 1, and then everything else is 0, right? Or wait, if both are 1s, that is an AND. So I got this backwards. So it'd be this way, right? Because if it's 0, 0, this should be a 0. I cannot believe my brain is doing this to me. NAND truth table, 2 input. Yeah. 11110. What the hell? My brain is not. Yeah. Okay. Nice. What? Is Consolos in here? What? Hey, Flask. My brain was thinking untruth table. Hello, Raiders from Virtue Lab. Is it virtual or virtual? Oh, I get it. Or is it virtual abs? Oh, thanks, Alex. That's what it is. Okay. Anyway, yeah, my brain just couldn't. Well, first it's because I haven't thought about it for a really long time, and second is I just forgot. So the idea here is, so I'm holding qual low. So as long as qual is low, then this will be a 1. And then if qual enable gets pulled low, no, so this is always pulled high. Yeah. That's actually what I want. Because then if I pull this low, then that's actually what I want it for. This one, this side is going to be different. So we are designing a state mode logic analyzer in KiCad using an RP2350. I actually made one version of this with a 2040, but I ran out of I/O pins for what I wanted to do. Now, a logic analyzer is a digital test tool that allows you to capture data in a digital system. Most of the logic analyzers that are available today are timing analyzers, which means they sample at like 100 megahertz and then just show you what they sampled. That's a relatively simple design to do, and there's like a bunch of PiPico and RP2040 and now 2350 based logic analyzers that do that. However, what I want is something that does state mode, meaning the device under test actually drives the clock or drives the sampling. And so in a state mode logic analyzer, so like if you're looking at say like a microprocessor, you would hook up to say the address bus, but then you have to also hook up to the clock signal so that the target's clock will drive the logic analyzer to cause sampling to happen. The advantage of this approach is it's significantly more memory efficient because you're only taking samples after the bus conditions have changed. It also makes triggering much easier because you're getting state mode views. It's also helpful because it allows you to see traffic on a data, like especially an address and data bus, the same way that the microcontroller would actually see it, because you're seeing the data get clocked in. The downside to it is if there's any kind of glitching, you won't be aware of it. And then that's its primary issue, is that you won't actually get to see any glitches. The other downside is you have to have a clock to sample with because the analyzer can't do it itself. So welcome everybody. Hope that makes sense. And yeah, we'll see. So let me know if you have questions. OpenSCAD. OpenSCAD is one of the coolest tools I think around in terms of CAD development, but it's the one that I'm least interested in using for anything other than really basic things. So, oh, the ring on the mouse. Yeah, that would actually be nice to have a duplicate of that. Okay, so now so then okay, so where I'm going right now is I'm actually trying to figure out how to, actually this shouldn't be buff clock, this would be clock. I'm trying to figure out how to add a qualifier signal, because a lot of this is based around how the old HP and Agilent logic analyzers worked. And so they had 16 bits on a pod with a clock and qualifier signal. Now in their systems, they were a little bit more flexible. You could have multiple qualifiers and blah, blah, blah. I'm going to have one qualifier. I'm going to allow one clock. And then I'm trying to come up with a circuit right now to handle the qualifier. And the reason I don't want to do the qualifier and the PIO is just a matter of right now I've got the PIO set up where I have 16 signals. Or I guess so. I guess I could do it. Wait a minute. I didn't think of that the right way. Maybe we will just put this into the PIO. Well, let's figure the circuit out and then I can decide that later. I need to try and see how that's going to work. Sin bleed, any change regarding voltage regulation? What do you mean by changing what? The 2350 maybe? Or my design or something else? Or the Pico 2. So the only real downside to this approach, okay, so the RP2040 is going to how do I want to do this? So the intermediate signal clock out. So when qualify enable is high. So actually, I just realized I probably do want this to be pulled down. Yeah, and if it's going to be pulled down coming from the 2350, I'll definitely be using external resistors. I have to actually go read the errata. I don't know what the actual issues are. And then this way, the only way that this will ever be active is if I take this pin high and that pin goes high. So then our intermediate, and so just so that it's clear what I'm saying here, and I'm going to rename this to buff just so that it's so then we've got a 0, 0. So then intermediate will only go, this will be a low. Yeah, so this doesn't work because if this goes low, then this will always be high. So I would need an inverter, or we don't use NANDs. Because if it was an AND gate, this is a little bit easier. This would be all zeros, right? And this would be a 1. And then this would be all zeros and a 1. This is probably what I want. I probably just want a regular AND. So tied 0, we'd get 0. It's not until both of these go high that we get a 1. We get a 1 out of that. And then on this one, then we would, if intermediate is 1, then it'll follow the buffered clock. That's actually what we want. Okay. Oh, hey, Flask. Thanks for saying so. Yeah, I'm actually pretty excited about this one because, like, when I was working on the Apple II, the Mega 2 project, the main issue I ran into was just that the logic analyzers, like the digital discovery, what's the 2 gate? 74 LVC 2G, yeah. So 74 HC 2G. LVC 2G? Okay. That'll probably be fine. But like the digital discovery, the more or less the one of the issues I ran into was I couldn't because it's sampling asynchronously and its trigger system only lets you do like match an address. The addresses weren't qualified. And so it would trigger as the bus was transitioning through states because for 2 reasons. One, because it would transition through states. And then the other reason is that it was designed for a 3.3 volt or less logic system. And so there was enough noise and especially in the address bus that the logic analyzer would get false ones because there was just enough noise to trigger its threshold, even though the Mega 2 didn't see those particular signals as a 1. So anyway, there was multiple issues that I ran into, and I really, really just wished I had a state mode logic analyzer. I really miss having the ability, and I think it's because for a decade I was a apps engineer for Agilent, and that was our primary advantage of our analyzers is that they were state mode. So to me, all logic analyzers should have a state mode. So anyway, thanks for coming to my TED Talk. Story that nobody asked about. Okay. So how do we think? Okay, so that's how this is going to work. So the microcontroller will pull qual enable high, which will then cause this to go high if qual is high. And then that would mean that this will now be sitting in the state where it follows buffered clock. That's not how I want this to work at all. That's not right. That's not right at all. Because I actually think I want this to be an and, right? Because or actually this one should have been the NAND. All right, let me back up a few things here. So if the enable signal is high and qual is low, then I want output to follow that. If the enable is low, okay, I'm doing this completely wrong. This doesn't make sense. Okay, I give up. We're just going to do it this way. I can't. I'm actually going to make a couple of changes now. Let's get all this out of here. Apps engineer for Agilent. Yeah, I would say so. T&M apps engineer was probably my favorite job throughout my career, because you end up working with some really expensive hardware that you would never you would very rarely get a chance to otherwise touch, and it's generally a company that T&M test and measurement companies are always pushing the bleeding edge of everything. And so like I used to say that we sold science fair projects because there were so many times where, well, especially when I was so my first job was FAE for PC companies, and our primary product I was supporting was the front side bus probes. So we had a interposer that would go between the processor and the motherboard, and then it would break out all of the pins on the processor, and then that would go to a box that was basically a big decelerator that would take the front side bus data and then decelerate it so that the logic analyzer could capture it, and then a bunch of software reconstructed it, but it would allow us to see what was the processor of the PC actually doing. And to get a lot of those to work, it was just a phenomenal engineering effort on the from the engineering team. But we would only sell like 20 of them, and so it was always funny to me because it was like we would get one to work in the lab, and then they would go to production and figure out all the other issues with it later. Like, because there was only 20 of them, and so even if we had to go and do fixes, like there were a couple of times where we'd have to like reflash the FPGAs after a customer received it. It was like, all right, well, it's better to do that because we can get out into the market faster and blah blah blah. Anyway, the downside to it is that if it was really hard to support because there were just so many things that if you didn't know what the FPGA code was and you didn't know what the frontside bus was doing, it was really hard for me to like look at it and be like, oh, I know why you're not capturing the right data. But anyway, yeah, it was really cool. I mean, I think RF is actually a really fun one too. Like RF instruments, just because that's where there's like I don't know, lots of specialized gear out there. I don't know what's going on. Why are these highlighted? So anyway, yeah, it was a cool job. I liked it. So my next thought then is, what if Christian is right? What if I can't get, well, I'm going to go with this for the moment. And then I need to figure out if this is actually going to work at all, because it may not. Okay. I don't know what just happened. I want it this, then all of this. Okay. All right. Let's stay there for the moment. So this, I'll have to play around with this and find out. I got to find out if we're going to have trouble getting the qual signal in here, as well as the byte boundary. Okay. The last thing, and I swear, and then we can do the PCB that I said we were going to work on. Because, you know, whoops. By the way, for those that came in with the raid, if you're following, if you're following, thanks for following. I forgot to say thank you earlier. Assuming if you're still here. Okay, so hey, unknown, good to see you again. The errata that was found on the 2350. The convention is that they'll have to come out with a differently named part, like 2350A2. Yeah, they probably won't change the, so maybe they'll come out with like maybe like a C and D, because there's already an A and a B, right? Because I think there's an A and the B, which is the difference in the case, in the pin count, and then there's the 50 and the 54. The 54 has the flash. They may come out with like a C and D and just do it that way, so that it's very clear that it's a different chip. But what they'll probably do is, with silicon, they're not called versions, they're called stepping. So you have like, usually, I guess it's usually letters, maybe it's numbers, I don't know. I guess it could be numbers. So Raspberry Pi uses letters. So this letters and then a number. So like a major stepping and then a number for a minor stepping. So I think they already have an A2 or A3. And so what they're most likely to do is just make a new stepping, which will be a B. And then they'll just start shipping those. And so you'll have to look at the chip itself. I mean, for low volume customers, you'll have to look at the chip itself to figure out which one it is. And then in software, they'll probably be able to tell which one. So you'll be able to probe it and see, you know, do I need to do the fixes for it? So I doubt they'll come out with like a different part, a completely new part number. I think if they made a big change, they would do like a C and D to add to the A and B. That's the only thing I could see them doing, but I doubt they'll even do that. Okay, so now the idea is I want to have two 16-bit pods plus clock and qual. So that's 18 signals, right? All right. So I want to do, and then power, con O2 by 10. I think that's 20 signals total. Oh, I see what I did. I didn't do 1 ground per signal. I did Okay. Hmm. I sort of want it to do. I don't know. Let me work through this. I sort of had wanted to do 16, 17, 18. Yeah. So this would have been a 20. But what I actually want it to do is this. I want it to connect this side entirely to ground. I'm going to move all of this over. Like if we did this and then I was going to say, but then I can do a label of N00, right? And then we can do this and that. Nope, nope, that. And then I can say, okay, well, I want this to come out to here. And we'll come all the way through here. And then have our clock and qual. And then have the 2 voltage rails. Or well, I'm going to do this. I just thought of 2 things I could do. And maybe this would actually be worth having for headers. But I was thinking something along this line. Yeah, the 2040 had a couple of issues, and I think there was like a stepping where like a really early stepping had a terrible ADC, and then a later stepping had a not so terrible ADC. So it's like, you know, it's not the first time. I mean, if you go look at pretty much any microcontroller, they all do it. This isn't something that is like really unique to the Raspberry Pi. This level of issue is probably not what you would normally see, but having to have like a stepping is not. I mean, that's pretty common. What's really interesting is there's the MCP something something something. It's a I squared C IO expander. Everybody has been using it for years as it's either 8 or 16 bit. I think it's 16 bit IO expander. Like it's all over the place. And just recently, I was looking at the data sheet and I realized they had made a revision to the data sheet earlier this year. And then I guess there was an article on Hackaday that I missed because I don't read Hackaday. But that IO expander, it was determined that there is a bug in the I2C handler that can mess up 2 of the bits. And so Microchip has now started calling it. They say it's a 16-bit IO device, but they're saying that 2 of the IO pins are only available as input, or should only be used as input because of this potential bug. You know, and so that's an example where if they fix that bug, they would probably just make a stepping and say parts manufactured after this date or this lot code or date code don't have this issue anymore, which is a lot like what microcontroller vendors do. So the 23017. Yeah, I just couldn't think of the name. I was really surprised by that. I named those wrong. Okay, that's fine. This should be in fall clock. But yeah, I mean, it's we probably think of hardware as not having bugs, but there's a lot of bugs in silicon. What's really cool, really really cool, and we were talking about test equipment earlier, is there's a lot of things that can get fixed like by changing the metallization layers. And so like I remember um, in my test and measurement days, we had lots of custom ASICs in our stuff. And it was just amazing to me how during development we would find a bug. Well, sometimes I would find the bug, but I couldn't. That I could just say, "Hey guys, it does the instrument does this when it shouldn't." It's like anyway. So, but it was interesting how many times they were like, "Well, we don't have to do a complete respin because we can just change the metallization layers to implement a workaround, and then that way the silicon itself doesn't change, but the layers of metal that gets put on top of it to basically do the interconnects, that doesn't require a complete redesign. That's just like later in the stage of processing. So they would just modify that one part of the stage." But it was shocking to me how many times it'd be like, "Yep, we'll have to make the change in the metallization layer." I was like, okay, well, I guess that works. All right. And then this is okay. All right, let me save that. I'm gonna go look at the PCB and see what this kind of mess looks like. Yeah, well, I think any vendor only publishes things when they really have to. I mean, part of it is, I mean, let's be realistic. There's like a range here. There's the stuff that's catastrophic that you really need to tell people about. There's things that are so corner case that it you don't want to necessarily alarm people that there's an issue. And then a lot of the stuff falls in the middle. But I think it's maybe that corner cases where we can sometimes get upset because if you encounter the corner case and it's not documented at all, you may not even think to contact the vendor to say, "Hey, why am I seeing this behavior?" On the other hand, oh, oh, uh, silicon vendors, they want to be they're really careful about they don't want to necessarily say, "Well, we have this 1,000 problems with our chip," because then their competitor is going to say, "Oh, but see, we don't have that many problems. They're just a terrible design. Look at all those issues you have to think about before you start using it," even though they have just as many themselves. It's I hope that makes sense. Anyway, I'm not saying it's right. I'm just saying I understand why sometimes chip vendors don't want to tell you about all the issues they know about. I would also point out there's probably a big chunk of times when they don't know about all the problems. Okay. Yeah, this is ridiculous. I don't need that many grounds. Okay. Yeah. That's just ridiculous. Okay. I'm not even going to bother. We're just going to. So I want to try to replicate this layout multiple times. So this is going to be probe low. I think we're going to make this a 14. Because I want to be able to do edit in clock. In qual. Wait. And then ground. Oh, I'm so silly. 13. That's not what I wanted. All right, first let's change the footprint to be 13. And now let's do edit and do change symbol and change this to a 13. There we go. And now we can just move this up and we'll move these up. Yeah, flood the unused areas with spare gates. Also, especially like in really like in test and measurement, it would also be common where they would say, okay, well, we're going to try this logic and we're going to try this logic. And sometimes it's like, okay, well, this logic has the bug, this one doesn't, or there's, they already, somebody has been doing it for 20 to 30 years. They already know where their most likely issues are going to be. So they might also implement like bypasses so that they can just say, okay, this feature just isn't going to work, and then we'll just move on. So is there a bug severity convention for hardware? No, not at all. I don't. Nope. Okay. We're gonna do it this way. This one, and then the reason I did this was because I want to be able to go like this. Nope. Go like this. Like that. And then we'll do this one and this one, which will go up to here. And this will be probe I. And then we will do a line to here. Copy that. Copy, paste. Nope. Paste. 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 And then I need a copy of the in signals, which is probably going to be faster to do. Yeah, I think I could just do it. I think I'm just going to do it this way. We'll just do in 16, go to 31, and then grab the evens, move these, rotate them, and we're going to do something like this, because then this one goes here and this one goes here. So I'm clicking and then hitting the M key for move, so it makes it quick to do this. All right, and then over here, whoa, where did you go? Let's move these a little bit closer just to reduce the effort. Man, I just watched the best toys or the most toys, the TNG episode where Data gets captured by a collector. That was a really troubled episode because the original actor that was guest starring had some mental health issues. And so they brought in somebody at the last minute, and he did a really good job. And it still continues to be one of my favorite Data episodes. Modeled the bottom. Oh, the bottom face of the ADB bus thing. That's cool. I'm looking forward to seeing how that comes out. All right, and then we'll move this up here. This roughly here. All right. And then I'll put these up here. Oh, we got to figure out what we're going to, no, I already got that covered. Okay. Okay, so now let's push that over. Update this. 3 warnings are cannot remove. Okay. And that's a heck of a lot better looking. The board is still going to end up much larger than I would like, but I don't know that there's a way around that. The only other thought I have, and I don't want to go this route, is to use something other than 2.54 millimeter connectors. It's like because the other thing I could do is make like an adapter that plugs in that's either 16 or 32, but then that way the overall logic analyzer board is really small. But I don't think I want to go that route. Yeah, so this is going to end up being like something like this will go here, and then I'm going to move this even though I don't want to. That will go there, and then one set of okay. We're gonna use a little thing called pack and go, just to get an idea of where some of this stuff is going to end up. At the moment, all I want are footprints. All right, I'm going to put this one over here because what I want to do is I want to grab this whole section of stuff. So what I'm going to do is, so I'm going to highlight, no, we're going to start because that's going to mess that one up. We're going to start with this one. I'm going to highlight all of these. I'm going to come over here. I'm going to hit P for pack and go. And now all of the parts that I just highlighted are connected together. Oh, I don't know what just happened. Shoot. All right, so they're going to end up all over here somehow. All right, I got to turn this off right now. Preferences. Cross probe should not. Where's the cross probe set up at? Schematic editor, display, zoom to fit cross probe. Yeah. There. Okay. I don't like when it automatically zooms. Not all 2.54 millimeter space through hull headers are the same size. Huh. Interesting. You mean the actual pins themselves aren't the same size, so they don't fit in the hole the same way? Because I could see that. That'd be frustrating to run into, but I could at least see that happening. All right, so, oh, nope. Forgot to go. Okay, so highlight over here, come into PCB, I'm gonna hit P, and then that brings all of these together. And then we can come down to this section, highlight these, hit P, oh, nope, did it again. Highlight over here, go to PCB, and then hit P. And then those are gonna go down here. And then we'll highlight these, come over here, hit P, and they're gonna end up right there. Man, that pack and go really, that really changes laying stuff out. When did KiCad get the iBomb output? That's been around since KiCad 5. That plugin is the number one plugin I recommend and use. It is by far the most useful. Well, I guess it all matters what you're doing. If you're doing hand assembly, it is a must-have. So okay. So this board is going to be, I wonder if we'll end up doing something. I wonder if it's going to end up being something like this, where it's like, edge cut. Like, is it going to end up looking like this? I think, where it's gonna be this kind of like long board. The other thing I was thinking about is, what is Arturo's third party? What does he call it? 50 Stamp XL. How big is this? I don't really want the footprint, but fine. We'll just. I really didn't want to do this at the moment. But for the sake of seeing where this is going to go, is that enough? Is that going to get me there? I don't think it did. Nope. All right. Well, what's he call it then? Oh, there it is. Okay. This is the footprint editor. Hmm. 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 Hey, RJ. Yeah, P feature, pack and go. That was maybe 7. They introduced that one, and it took me a while to understand how it works, but it's really great for, well, what I was basically showing it is like it's just, well, actually this is a good use case here, where I can go and grab all of these, pack all this together, and be like, okay, now we can go and lay all that out where it belongs. But it just makes it really easy to sort of group stuff together. It it solves that initial layout problem of, well, why doesn't the PCB match the schematic, which that's rarely actually what you want, but you do at least know that, or if your schematic is at least grouped where like there's certain things together, it'd be nice if you could get all those things to show up together. So yeah, yeah. Well, I remember seeing a demo of it and I was like, that's really cool. And then I went and tried to use it and it took me a really long time to figure out, oh, this is how it works. So anyway, what I've been thinking about doing is using this Stamp XL instead of doing the whole RP20 or RP2350 thing myself, which I was oh, here it is. So it's basically, it's got the chip. Um, I think that's an external ROM flash, uh, a actual reset button, and then it also has stuff for charging. I think for charging batteries, but I don't care about that. But it's not. It's I think it's like $20. Oh, so it's like $11, and I just have a feeling that would be a lot easier to implement than. Wait a minute. This should be over here. hold on. These should be over here. These should be over here. And then this should be like here. That's sort of how that's going to look. But man, if he's only charging $11 for that, that might be the way to go. And then that way I can just focus on the code instead of trying to deal with getting all that stuff built. So I really like that. That's really sexy. Hmm. Yeah, I'm going to give that some more thought. Or seven, yeah. So you're so yeah. So it was the case of the header holes were just a slightly different size. Yeah. I, as far as the sizes go, I don't know. It's something that's only bit me once or twice, and so I never really think much about it. But again, I don't do a lot with through hole, and when I do through hole, it's I already have these part numbers that I use, so I just don't give it any thought. So, and then do a double sided to make it even smaller. Oh, good point. Well, so the trade off there, and I might say to hell with it. The thing that's really exploding the size right now are the test points, because I guess yeah, okay. Basically do like for lack of better, just to could basically do something like this. And then like have these like on the top and the bottom. You know, I'm liking this. I like this idea, because then this massively reduces the cost. And there might be like might even be able to do something where maybe we like put this like in the middle here. Like I'll just draw it like this, but then this stuff can maybe get spread out. Yeah. Hmm. Yeah. 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 Dual roll of the test points. Mm. Mm-hmm. Mm-hmm. Yeah, you know what I could do? I mean, the other thing on the test points is I could just reduce the test points. I just wanted something because I thought I'd want to be able to clip onto them during my development. So I think I want to keep them. But these test points are actually really terrible for easy hooks. So I should look for something smaller anyway. Another thought I just had is, what if I just put all the test points on the backside so that they're there and available, but then we could even kind of smush things in even more. Another thing I can do is I could reduce the number of ground pins and shrink up the connectors a little bit. I'm not sure. Yeah, I just don't like through hole test points. But those ones with the colored beads would actually be pretty ideal. But like you said, we could just like double them up. So what we could do is just have we could just like have those could just be like, oh, you can't see me. So do like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like just do a just do that. Yeah, because though even though I don't generally like those test points, they really would work well for what I would have for hooking up another logic analyzer. Simply do not write bugs or make faulty electronics, and you don't have to do test points at all. Yeah, no kidding, right? Why are there even test points to begin with if people just didn't make mistakes? It's kind of like why have a debugger? You know? Yeah. Hmm. Yeah. See, his little dude. Okay, I don't know. Big test point is sabotaging our projects. Yeah, yeah. Testing's overrated. You know, okay, so I have a couple of thoughts. Number one is I still need to do the voltage regulator for the IO, so that'll have to go somewhere. I'm super tempted to put like an OLED screen on here just to have real time status information, or at least put a header for one. Oh, maybe that's what I could do too. Is what if I put a header for one of those little OLED modules and a stemma connector? I'm trying to. So unknown on Twitch said, "Why version your parts? Just make the best one possible." Um, I'm trying to remember. It was actually it was when I graduated school. I started as an apps engineer, and there was a kid that started with me um, at the same time. We were both in the Austin office, and he didn't have as much practical experience as I did. So I did an internship at Dell the summer before. And so I had actually used the logic analyzers we were supporting as well as the scopes and stuff. And I remember we were in training together and somebody said, okay, well, on this version of the card, uh, it was something related to the trigger system works this way, but on all the newer versions, it works this way. And he asked, well, why didn't you just do it right the first time? It was just hilarious because it's like, well, yeah, obviously they didn't screw it up. They didn't screw it up the first time on purpose. It was a bug, and then they later fixed it. So it's just like, and it was like one of these cases where because we were working with Intel systems, those customers generally got the cards right off the line. Like they would get a lot of times they'd get pilot runs, and so they tended to have the most bugs. So we would anyway. It was just funny. Okay. Um, I think that's as far as I'm going to get on this one tonight. Um, After putting this solder or this 2350 XL module down, I'm really tempted that we just go with that. So maybe we'll adapt that. I don't want to deal with this QFN. I don't think I'm going to enjoy that. And me drawing out this part of the circuit adds zero value to what I'm doing. I'd rather focus on the other things. All right, so let's go ahead and save that, even though that's a terrible layout. So there's still a couple things we're going to have to do over here. So let me just make a couple of notes. Whoops. So switch to stamp XL. We need to do add LDO with Digipot, and then, which means we can remove the 3.3 volt that's on here right now, because we won't need that. Add OLED header. I'm really liking the idea of having an OLED screen just for whatever. I just think it'd be nice to know what it's doing or what it's seeing. Do I need the XL version? Yeah, I think I do. Because, well, at the moment, I think I do, because we're already using 35 GPIOs, and that doesn't even get us to some of these other things, which, well, some of these signals we don't need anymore. We don't need a counter signal. Arm trigger. I don't even know what this one was for. I guess that's just a blinky thing. LA enable, I'm not even sure what that is. So I don't know. How many IOs are there on a Pico? Or what's the other stamp? You know what? Now that I say that, I don't even know how many IOs did he make available on this one. 30 GPIOs. Yeah, that's not enough. Yeah, so we need the bigger chip. But yeah, man, I really think the more and more I think about this, the more I think I'd rather just go with his stamp and leave, because he's going to get parts way before I get parts, or JLC gets parts, or anyone, right? I think maybe. I don't know why I said JLC. I meant PCB way. I'm never ordering from them ever, 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 ever. Oh, that last email they sent me. Someday I'll share it with you guys. It was the crudest email I've ever gotten in response to me being rude from somebody who wants me to do things for them. Like, I was in total shock. So anyway, like, I already thought they were a garbage company to begin with, and all they did was prove that I was right this entire time. Like, for a while, I thought maybe I was blowing things out of proportion, but it turns out, nope. I'm almost positive the person that sent it is the person I've dealt with for years. So, because it's the same kind of style of, anyway. Yeah. Well, I mean, actually, once the 2354 comes out, it's going to be a little bit easier, but yeah, I don't know. I just don't want to deal with designing all the other stuff. So, all right, I think that's where I'll stop there. That's I'm running out of steam. I really wanted to get to the PCB today, so I apologize that we really didn't, but made a ton of progress. I mean, really, I guess TZ is probably gone now, but switching to these dual transceiver buffers, I think is a great idea. We'll need to design up a variable output supply for those. So we'll work on that next time. That actually means, okay, we need to fix the decoupling caps for the transceivers. We'll need to do that. So what's the part number on those buffers? Yeah, I'll zoom in so you can see it. It's a 74 LVC 8 for 8 transceivers, T245. And then they have, so the A and B sides have their own voltage supplies. And so the idea where I'm going to go is the side that's connected to the RP2350 will be stuck at 3.3 volts, but the side that connects to the target, I want to wire up a regulator with a digital pot so that we can change its reference voltage. And so basically what I want to be able to try to do is say, okay, well, on these signals, let's move the voltage threshold around a little bit and see if we can't make it a little more granular. So that's the goal there. I'm also thinking, I just now thought we could go really extreme, which will then make this board much, much larger, is we could actually do this in groups of 4. And then that way we'd have a little more control over, like, well, what if part of what or maybe, I mean, actually what I could do is go so far as 1, 2, 3, 4, is what if we made 4 power control circuits and let each group of 15 or each group of 8 have an adjustable voltage threshold. Hey, Harold, it's good to see you. It's been a long time. You might learn something. Yeah, I don't know about that. Yeah, actually, I'm wrapping up at the moment. I'm running low on energy. Yeah. Okay. Yeah, we'll stop there. Because I just now remembered I've got to finish a video tonight, so I need to get onto it. But anyway, real quick, what I'll say, since you came in, Harold, we're making a state mode logic analyzer. So back in the 2000s and well before that, Agilent and Tech, their logic analyzers had 2 modes, timing and state mode. Timing mode is what almost every single logic analyzer you buy today does. It samples asynchronously and then just gives you, does a high-speed asynchronous sampling. State mode logic analyzers, and here's the key, is that they get their clock from the device under test or the target. And so, like, if you're probing a microcontroller address or microprocessor address and data bus, then this analyzer will only clock in samples when the clock transitions, just like the processor is seeing. What we're going to do inside the RP2350 is I've already prototyped a PIO program that will allow me to delay the clock, so that you can actually delay the clock a little bit, so that you can make sure that you're closer to the middle of the data valid window for the data you're capturing, and get valid data into the logic analyzer. It's a really highly efficient way to analyze what's going on a bus, because you don't have a ton of extra samples to deal with. You're only seeing things when something interesting happens. The downside to it is you miss any kind of glitches or issues like that. But the idea is once you've already validated your signals are in good shape. Like when we're working on the Mega project, there were so many times where I just wanted to watch what were the addresses that the chip was bouncing around on. And it was really difficult to do that with a timing analyzer, because it would see all the transitions and it would just make a mess of the display. So Is this going to be something that gets attached to an existing LA or a module on its own? Right now, right now it's just going to be a module on its own. When later on, when I get better at FPGAs, I would actually like to make a module for the digital discovery that would actually sit in between and basically do this for you, where it would basically only give a qualified state to the digital discovery. But to do that with an RP2040 I don't think makes sense. Or with an FPGA, that'd be brain dead. And in fact, even this whole project, it probably makes a lot more sense to do this in an FPGA, but the PIOs make this so interesting. And so in my grand vision, what I'd like to do is develop this where I have my board that has its specific hardware. It does 32 signals. So I have this one, and then use that same code on a version with the Pi Pico and Pico 2, where it's like, okay, well, if you only care about 8 signals, it should still work for other stuff, just with less features and capabilities. Because I really think once I get this worked out, I think people will see the value of a state mode logic analyzer, especially if people are working on retro computing or retro video game projects. I think it'll be much more useful than trying to hook up or than trying to analyze with a timing analyzer. So when does the SIGROC driver due? Yeah, exactly. It'd be interesting to see how much test equipment you can make with a 2350. Yeah. Like, I mean, it's just interesting how much stuff you can do with it, where before it came out, and what's actually kind of funny is before it came out, there's other microcontrollers that have things like the PIO. It's just something about their implementation was so good that it's like, oh, it's so simple to use, but it's so powerful, and it's ridiculously fast. I mean, it runs at clock speed. So yeah, building a frequency counter with one would be very little effort. In fact, one of the things I'm doing, and this is actually, it's really easy to do like a frequency counter with the PIO. So I was going to show my code real quick, is that, or in my code, so I have a PIO program. So this first PIO program, it basically delays the clock. So the ARM side gives it a value, and then it basically says, okay, well, I'm going to run through and I'll delay for that many clocks, which at the moment is running 125 megahertz, but I could deal with that later. And then this will delay the clock. So I can actually, like I said, I could effectively move where my sample clock is, before I sample the data. Now, in this code, this is actually outputting a signal, which is not really useful. This will actually do a fire and interrupt, which will cause a sampler to happen. But then I also have a counter, and this is hilarious to me. All this is doing is nonstop counting down, and this way I can say, okay, well, between X and so I'll take a value. So a clock will happen. I'll get the value of the counter. The next clock will happen. I'll get the next value of the counter. Subtract the two, multiply by, what was it, 8 nanoseconds, and that's how much time has passed, right? It's like, wow, that's really cool. That's really easy. That's a lot easier than trying to set this up in an FPGA. So anyway, only brought that up because you could do something really similar with for a frequency counter. Is you could actually basically do something where it's like, okay, well, every time you overflow, or you just have this counter running really fast, and then figure out what you do from there. Which, by the way, I did not realize this, and I don't know how I missed this or I forgot this, but the RP2040, they don't have general purpose counters. Like they have a couple of timers, and that's it. And the timers are tied to the system clock. Okay. All right, guys. For those on YouTube, thanks for joining. For those on Twitch, we're going to go raid. We'll go raid Sid. Yeah, we'll go raid Sid. See what he's up to. Last week he did a 24-hour stream. I was like, that was like crazy. And then let's see. So next week, we'll probably be working on this next week. There is a LoRa project that I want to work on, but I need to do some pre-work for it, and I probably won't get to that before next week because I'm finishing a Workbench Wednesdays video that may never come out. And then I have the Cerberus video that I want to do for, maybe that's what we'll do next week. Maybe we'll do that. Anyway, we'll do something next week. Subtract 2.5 hours from whatever time it is for you, and that's what time I'll be back next week. So thanks again, guys. Appreciate you coming. And remember, find time to do something you enjoy. And if you do, please share it with other people. All right. Take care. Thanks. Bye. That's the button. Also, like and subscribe.